On the edges of our close by planetary bunch there exists a little heavenly body. What's more, trapped by a hurtful cover got comfortable. The middle of the colossal range of space, a monster shadow looms over its extreme horizon, covering the stars from view as the weak sun easily crosses the sky. Its feeble pillars fight to disseminate the semi-murkiness that covers the frozen plain stacked with perpetual bluffs. Welcome to Pluto, a forsaken space of rocks and ice shrouded in ceaseless shadow. We ought to dig further into the insider facts of this far-away world. Pluto, organized approximately 40 galactic units from the Sun, shows up as a dull and unclear item this far off. Body chases after a drawn-out circle. The planetary framework community finishing its excursion each 248 Earth years. In spite of having a width of only 1,188 km, more modest than the planets as well as, indeed, even a few satellites like the Moon, exact perceptions of Pluto's appropriate movement permit us to decide its mass at a simple 1.3 by 10 to the force of 22 kilograms, or 1/118th of the lunar mass. Pluto shares more similitudes with more modest heavenly bodies like Ceres or Sedna, acquiring it the assignment of a Bantam planet in 2006 on account of its extensive circle. Pluto flaunts a lengthy orbital cyclet, as it were, pushed toward its perihelion, coming as close as 29.7 cosmic units to the Sun in 1989, more than 2 centuries later. Its disclosure, the distance has consistently expanded and is projected to arrive at its greatest worth in 2113, when Pluto will be close to its Elon, at 49.3 cosmic units from the nearby planet group Focus. Hence Pluto remains as a far-off and swoon space object, imperceptible to the unaided eye from Earth, showing up as a faint earthy-colored plate, without surface subtleties even in pictures caught by the Hubble Space Telescope. To conquer the difficulties of considering Pluto, the new Skyline's automated orbital station passed on, determined to investigate the Bantam planet in 2006. After a 9.5-year excursion, the rocket came to Pluto in 2015, catching nitty-gritty pictures and assembling more than 6 gigabit of data during its flyby, in spite of the fact that the test's direction forestalled a extensive overview of Pluto's whole surface. The information sent to Earth, given critical experiences as of now. How about we dig into Pluto's inward structure as indicated by the ongoing model? At its center, Pluto flaunts a huge, generally 1,700 kilometers distance across structure of different types of water, ice, and shakes encompassing. This center is a 300 kilometers ice mantle, potentially going through structural cycles that are as yet not completely perceived. The mantle thus is covered by an outside layer comprising of set gases like nitrogen, methane, and carbon monoxide. A few speculations propose that Pluto's center creates sufficient intensity to dissolve segments of the cold mantle, possibly holding onto a pungent and harmful sea underneath the surface. Concerning Pluto's surface temperature, it remains incredibly low, not surpassing 6K short, 213 degrees Celsius. Our excursion around Pluto starts with an investigation of its most unmistakable component, Tomar Regio. This broad district, looking like a heart-molded sketch, rules the planet's surface. Pluto's hub of pivot has a critical slant, and the planet go through cyclic movements due to the gravitational impact of its huge satellite Charon. The Pluto-Charon framework is clean-locked, consistently confronting each other with similar sides. Pluto's loved ones of moons, including NYX and Hydra, found in 2005 and later revelations, like Kerberos and Styx, are a lot more modest and have unpredictable shapes. These moons, going from a couple of kilometers to not in excess of 16 kilometers in distance across, are principally made of water, ice, and conceivably got caught by Pluto's gravity from the Kuiper Belt. Currently we should examine Charon. While not Charon was all caught by the new Skylines tests cameras, the noticeable surface uncovers fascinating highlights. Southward of the equator lies a tremendous locale called Vulcan Plum, traversing no less than 400,000 square kilometers. Similar to the size of a normal European country, here the most elevated highest point on Charon Kubrick. Mons, with a width of around 40 kilometers and an assessed level of 4,000 m, sticks out. Some accept Kubrick Mons may be a cryo spring of gushing lava, recommending that the region around it might have sunk because of the heaviness of an underground supply. Moving north close the shaft, we track down the Goliath Macula with a width of 475 kilometers. Its starting point is still discussed, yet a typical hypothesis recommends that nitrogen and methane from Pluto's ATM sphere got caught by Charon's gravity, settling at its posts. Later openness to bright radiation changed them into tholin, which continuously gathered in the heavenly body's ice. Anyway, this speculation anticipates check through future missions, as Charon remains generally strange to us, regardless of being one of the most interesting structures in the planetary group. The Pluto Charon framework is understudied, with the new Skyline test having left the region some time in the past and the heavenly bodies themselves moving away, taking their privileged insights with them. The test, as of now, more than 50 galactic units from Earth, sometimes communicates significant information. However, by around 2030 its frameworks are normal to bomb, leaving it deserted in the endlessness of room. Pluto's unmistakable qualities reach out past its actual construction and circle its meager air, fundamentally made out of nitrogen with hints of methane and carbon monoxide, is a huge concentration of logical interest. This air goes through sensational changes as Pluto circles the Sun. When Pluto is nearer to the Sun, its surface is sublimate into gas, briefly thickening the climate. As it moves further away, the environment freezes and falls back to the surface as snow. These occasional varieties are remarkable and offer a captivating look into the dynamic processes happening on this far-off world. Pluto's environment additionally shows dimness layers saw by the new Skyline space apparatus. These layers are logical, framed by complex substance responses set off by daylight separating methane atoms. The subsequent intensifies then structure minuscule particles that make the notice cloudiness. This cycle is like what occurs in the environments of other external nearby planet group bodies, for example Titan, Saturn's biggest moon. Regardless of its little size, Pluto has a shockingly changed and complex scene. The new Skyline's main goal: uncovered mountains as high as 3,500 m, tremendous fields of nitrogen ice and organizations of valleys and edges. Quite possibly of the most striking highlights is Sputnik Plana, a huge heart-formed nitrogen ice plain that gives off an impression of being geographically dynamic. This district shows proof of convection cells where hotter ice rises and cooler ice sinks, making a continually recharging. That's what surface this action proposes. Pluto's inside holds some intensity, conceivably from radioactive rot driving these topographical cycles. Another interesting part of Pluto is its potential for having an underground. See, a few models recommend that a subsurface expanse of water and smelling salts could exist underneath its cold outside layer, kept fluid by heat from the planet's center. What's more, the radiator fluid properties of alkali. Assuming such a sea exists, it could give a natural surroundings forever, but in conditions unfathomably not quite the same as those on the planet. This chance makes Pluto a subject of astrobiological interest close by. Moons like Europa and Enceladus, which additionally harbor subsurface seas. Investigation of the Kuiper Belt, the area of the planetary group past Neptune where Pluto keeps on being an outskirts. For logical revelation, the Kuiper belt is populated with numerous little frigid bodies that are leftovers from the nearby planet groups. Development concentrating on these articles can give bits of knowledge into the early sunlight-based frameworks, conditions, and the cycles that prompted the development of planets. Pluto, as one of the biggest and best concentrated on Kuiper belt objects, fills in as a key to figuring out this far-off locale. In the next few decades, missions to the external planetary group will probably get back to Pluto and its neighbors, furnished with cutting-edge innovation to reveal more privileged insights future tests might convey. Instruments fit for infiltrating the ice to investigate potential subsurface seas, investigate the synthetic creation of the environment and surface in more significant subtlety, and guide the geography of these far-off universes with remarkable accuracy. As we anticipate these future investigations, Pluto stays a image of human interest, and our mission to grasp the universe. The information acquired from concentrating on Pluto not just improves how we might interpret the sun-powered framework, yet additionally rouses us to proceed investigating the obscure, pushing the limits of what we know about our place in the universe. Meanwhile, we urge you to remain drew in with the most recent improvements in space investigation. Your advantage and backing are essential as we adventure further into the last outskirts. Thank you for being a piece of this excursion. Stay tuned for more energizing revelations and experiences as we keep on disentangling the secrets of Pluto and then some. Pluto, often referred to as a dwarf planet, continues to fascinate scientists and astronomers alike. Situated in the distant Kuiper belt, it represents a relic from the early days of our solar system's formation. This region beyond Neptune is home to numerous small icy bodies, providing clues to the conditions and processes that shaped the planets. Since its reclassification from a planet to a dwarf planet in 2006, Pluto has garnered significant scientific interest. Its small size, about 1,188 kilometers in diameter, makes it challenging to study from Earth. However, advancements in space exploration have allowed us to glimpse this distant world in unprecedented detail. The New Horizons mission, launched by NASA in 2006 and reaching Pluto in 2015, provided groundbreaking insights into Pluto's composition, atmosphere, and surface features. This historic flyby captured detailed images and data, revealing a complex and dynamic world far different from what was expected. Pluto's surface is composed of nitrogen and methane ice, along with traces of carbon monoxide. One of its most prominent features is the heart-shaped region known as Tombaugh Regio, which dominates its surface. This region, named after Clyde Tombaugh, who discovered Pluto in 1930, showcases diverse geological features, including mountains, valleys, and vast plains of frozen nitrogen. The atmosphere of Pluto is thin but dynamic. It primarily consists of nitrogen, with methane and carbon monoxide contributing to seasonal changes. As Pluto orbits the Sun in an elliptical path, its atmosphere undergoes sublimation, where solid nitrogen and methane turn directly into gas when exposed to sunlight, resulting in temporary thickening and thinning of the atmosphere over time. The moons of Pluto, particularly Charon, play a significant role in its orbital dynamics. Charon is large compared to Pluto itself, and they form a binary system where they are tidally locked, always showing the same face to each other. This unique relationship influences Pluto's rotation and possibly its geological activity. Recent studies and analyses of data from New Horizons have led to discoveries such as possible cryovolcanoes and subsurface oceans beneath Pluto's icy crust. These findings suggest that Pluto, despite its distance and cold environment, may harbor complex geological and possibly even hydrological processes. Future missions to the Kuiper belt are expected to further explore Pluto and other dwarf planets, aiming to unravel more mysteries about their origins and evolution. The study of Pluto continues to inspire new questions about planetary formation, the dynamics of small celestial bodies, and the potential for habitable environments in the outer reaches of our solar system. In conclusion, Pluto remains a pivotal celestial object in our understanding of the solar system's history and diversity. Its exploration not only sheds light on its own mysteries, but also informs broader scientific inquiries about planetary systems and the conditions necessary for life. As technology advances and our knowledge deepens, Pluto will undoubtedly continue to reveal surprises and contribute to our evolving understanding of the cosmos. Stay tuned for further updates and discoveries as we delve deeper into the intriguing world of Pluto and the Kuiper Belt.